Hello everyone, welcome to Vega IT's technical podcast, the first episode. Today my guest will be Sandro Mancuso, Software Craftsman and the co-founder and managing director of the Codurance company. We will be talking about the topics of software craftsmanship, system design, architecture, and low-code, no-code, and AI tools. Stay with us, and I hope that you will enjoy this episode as much as I enjoyed it talking with Sandro. So, let's just start with something easy. So, how do you spend your days now that you're also managing director of Codurance?
It's a good question. I've never been, like though that kind of when people talk about imposter syndrome, and this is or being out of your comfort zone. This is my day today because like everything I do, it's so broad. Like running a company is not something that I prepared myself to,
Yeah,
right?
yeah.
So you have this engineering background, and all of a sudden you are discussing marketing and sales and expansions and salary reviews, and like so is everything is there is a challenge in there that we are not prepared.
Mm-hmm.
So my day is spent like across completely different things. Every meeting is completely different from the other,
Mm-hmm.
and that feeling of being uncomfortable or out of your comfort zone is a constant. So in a way, like I deal reasonably well with that because I like the challenge. But yeah, the days normally they are quite long days, very busy days full of meetings, not enough time for me to do work on my own, like have that peace and quiet that you just do work in isolation. That's very rarely happens nowadays, but it's enjoyable. It's different from what I used to do.
And do you ever get a chance to like join a project or do some programming that's for a project, or it's a now long story that's behind you?
No, so working full time, like proper writing production code and picking up user stories, that's no. What I normally do is I like to start some of the key projects. For example, when there is a new project or an existing project that will enter a exciting phase or something a bit more challenging. So I normally I speak to the clients at that stage. I still run discoveries. I advise with architecture or how the teams could be structured, but it's more like a strategic kind of role.
Mm-hmm.
Writing code in production is more like to have fun every now and again to pair with someone, but it's less so. I would still love to do that. I like
Yeah.
doing that, but I think that when you talk about the value that each individuals bring and where they bring, that would be a poor return on investment for some, or that's not how I would contribute the most nowadays. There are people that in our company can code probably far better than I do, or are more up to date with the modern technology as well.
Yeah, so I think you just how to say touched a very important topic that people who are software engineers need a long time to figure out, and this is the thing that when you move from the role of an individual contributor, so a software programmer, to a role of a team lead or someone uh, whose actions affect a bigger team, it's very difficult to detach from 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 the coding part. How
Yeah.
did you overcome that? Was it just like a realization point, or you had to work on it? And how do you advise people in your company when they move to a team lead or a higher position?
It's a mix of both. There is a self realization. Um, and like there is we have those chats among ourselves, and we were discussing the what it means to become a senior engineer, right? So what it means to become a senior person. And one of the things that we talk about, of course, that I'm answering this question more within a context, and the context is um, software companies like ours, right? So, in companies like ours, like Vega IT and ours, quite a few others, becoming a senior means becoming a multiplier, right? so
Yeah.
so I think that your value goes beyond than just the direct outcome of your work.
Yeah.
So when you are a junior, you take some piece of work, you work on that, so your value is directly related to the direct outcome of your work. Becoming a senior,
Yeah.
you start enabling more people to work well. So you multiply the value that you individually bring. And for that, you will work less so in activities that you work in isolation. You end up being involved in activities that more people are involved. So that's how I see that. So it's the kind of value that you bring, and you need to multiply. And that's why you end up doing different types of work.
Yeah, and the value that you bring is not anymore just the code that you put out, but the output of the whole team that you affect or that you work with. That's
Exactly.
I know that for me personally that was a very difficult thing to understand, and I think it took me a couple of years, to get from one point where I'm just an individual contributor, where I'm actually enabling a team to perform well.
Yeah, the difficult thing for most of us is because we have a passion for coding, right? So we like writing code, we like building software, and then you have that conflict sometimes between what you like doing
Yeah,
and what needs to be done,
yeah, and what's
right?
beneficial for the company and the whole team. Yeah, exactly.
Exactly, and this is for me like when we talk about software craftsmanship and being a professional, right? So this is quite important because like one thing is me having fun at home and
Yeah.
building my pet projects and stuff. Another thing, you being in a professional environment where you are being paid to do a job. There is a company that is paying for that system, and so you as a professional understanding what needs to be done for that project, that company to be successful.
Mhm.
And then there is what you like doing. Hopefully most of those things, hopefully you have a big overlap between the
Yes,
two.
exactly. Yeah.
That's when you can really have a very fulfilling career. But you always need to understand that in a professional environment, you are there to do what needs to be done, right?
Yeah, exactly. Thanks. And well, you mentioned the software craftsmanship. So you published your book, The Software Craftsman, in 2014. So it was almost a decade ago. So apart from the technology, has anything changed in the part of the craftsmanship?
There are things, of course, that it would be crazy just to look back almost 10 years ago and think that nothing would change, right? So I don't think that anyone is that visionary that say, look,
Yeah,
what I'm going to
exactly.
write today is going to be true in 10 years time. There are still a lot of things that I like. I think that there are many things in the book that still holds true to
Still
me,
relevant. Yeah.
still relevant. There are things that what changed dramatically for me personally was when I wrote the book, I wrote from a developer's perspective, almost an employee perspective.
Hmm.
10 years later, I spent most of my time on the other side of the table. So, as a company owner, as an employer, as someone that needs to deal with clients myself or pay salaries, making sure that everyone can be paid next month and the clients are satisfied and so on. So this the experience that I acquired in the past 10 years, if I had to write the book again, I think that I will have other perspectives added to it, right? So I think that I would emphasize a little bit more the professionalism side of things, the making sure that you are satisfying. So if you are hired, if you are being paid to do a job, that you focus on getting that job done in the best of your abilities and not just, hey, I will do whatever I want, right?
Yeah, yeah, yeah. And this is the question that I had for later, but I think it now goes well. So I would say that people in our area of expertise, so in software engineering, are, let's say, in love with the technology in engineering, most of them, right? And especially in the beginning of their career, they are or we are so focused on creating the best possible solution that we forget that there is a reason why we create this software.
Mm-hmm.
So if you would have to, or what advice do you give to junior engineers coming into the area that you see that are very, how to say, eager to be technically excellent, let's say that way?
Yeah, so like this is another thing that I would probably emphasize a little bit more if I was
Hmm.
writing that book today. So there were many things that happen in the craftsmanship community, or people that really are passionate about the skills. The good thing is that we all want to do a good job, right? The people that are passionate that we're talking about, we want to do the best job we can. And this is massively positive. But as you said, one of the side effects is that sometimes you lose sight of what needs to be done.
Yeah.
And then there is this discussion in the software craftsmanship world. It's like there is this focus on excellence, almost like this obsessive focus on excellence. But there is the whole thing called pragmatism as well.
Mhm.
And pragmatism received like it was almost considered a bad word. If people say, oh, we need to be pragmatic, it was mistaken by, oh, we need to cut corners.
Okay.
So then how do you balance that? And I swear, like, I spent a long time trying to make sense of it, because those are debates that we have inside co-students today. Right, so we need to deliver software to clients, similar to you guys at
Yeah.
Vega IT, right? So you are professionals, there are clients that are buying the service that you all offer. So the way that I deal with that today is excellence cannot be unbounded. So when there's no boundaries to excellence, you lose sight of what needs to be done. So how do I combine the two? I think that we need, first of all, when we are building something, we need to understand what are the real constraints that we have. And by constraints, time is a valid constraint. Money is a valid constraint. Some regulations or certifications or some
business constraints.
compliance, right? So those are valid constraints, or certain commitments that the company has to certain technologies or vendors, so those are constraints. So when you want to really understand what are the real constraints and which are not real constraints, for example, things that you could improve. So once you understand what the real constraints are, the ones that you say, you know what, it's not worth it trying to change this, that's when you draw a pragmatic boundary. For example, Black Friday happens once a year. Christmas happens once a year. If that feature is not ready by Black Friday or the Christmas, you need to wait another year.
Yeah.
So you don't have an option. You need to get that done, right? One way or another. So and this is where you say, like, what is the best job I can do within the valid constraints that I have? And this is what I call the pragmatic boundary. So if we are able to create a pragmatic boundary, so like, those are our constraints. And then within those constraints, that's where excellence exists. But this is, for me, the healthiest way to deal with that. We have the debate, what is possible to achieve? And then we'll do whatever is the best we can within what is possible.
Yeah, I think that very often we forget that we are creating software for the purpose of solving a business problem, and that we have to respect those boundaries in order to make it on time within the budget, and to solve the actual problem and not be technically excellent at any cost.
Exactly, because sometimes we only take the technical trade-offs into account and not the business trade-offs. Because sometimes you say, no, yeah, but if we do that, we have this problem. If we do that, we do other problem. But the business has constraints, as I said. So, like, sometimes it's better to try to have features that are not so well developed, but they are out for Black Friday.
Yeah, and
than
they
not
work.
having them at all and miss Black Friday.
Yeah.
Right?
And lose money that actually is used to fund the further development. Right?
Exactly. So those business trade-offs are the things that we need to get better at understanding. And we also feel that is someone else's job to explain. No, we should be the ones. So when we are building software, we should be the ones going to the business and say, like, tell me what are the constraints here? What are the pros and cons of doing this? I can tell you, like, we can do this thing in multiple ways.
Exactly, yeah. Yeah, it's software. We can do it basically any way you want it, but we need to know from the business what their constraints.
Exactly.
Cool, thank you. To go back to the craftsmanship, so you often speak about TDD and creating unit tests, but from what I understand from you, and I agree with it completely, TDD is not just unit tests, but it's basically a battery of tests that you create for your software, right? And what I see is when we have like junior programmers or someone without too many experience, they start writing tests, and when you look at tutorials, when you read about it, it's very simple, it's straightforward. But when you actually go to the business and try to create a test case, it gets quite a bit difficult. Like,
Yeah.
do you test for the outcome of your algorithm, or do you test for the dependencies if they're being called in the proper way? So what do you suggest to young engineers how to approach this problem?
It's a difficult question because it's very broad. But like I remember I had a talk. I gave that talk on a whiteboard. I think I called it something like TDD does not lead to good design or something like that. And the point that I was trying to make, of course, it was a provocative title. But the point that I was trying to make was that it's very difficult to do TDD well or to write tests well if you are not able to design well and understand well how your bounded context should be separated. Because this is the thing, right? So the most difficult thing is to decide at different levels what is the unit under test. So this is what I call the boundaries. So for me, the TDD has well, not TDD, automated tests. They
Okay.
have two different sides. There is the boundary. So what is within the boundary under test? Yeah. And then there is what you are trying to achieve with that test. So what is the goal of that test? Because, for example, if you go to the low level, what some people will call unit test, and if you are using like a OO language like Java or C Sharp, most people, most teams would consider the unit under test or the boundaries to be a class or a method, right?
Yeah.
So that's normally what we would say because it's a very, very well defined boundary, right? It is a physical boundary. So the unit under test, the boundary is the class. And then we say, okay, but what is the responsibility of the test? Quite often at that level, the responsibility of the test would be to check the correctness of that class from all possible perspectives. And that's why we try to poke that class from all different directions and make sure that every single permutation in there is correct. But if you wrote tests like that for all the classes that you have individually, and some of them you need to mock the boundaries and so on, so forth, we can go into that. We can also talk about defining the unit under test. But let's say that you have classes for all tests, tests for all classes. So then if you want to do a test that is at a higher level, which means you will need to put a few. So the unit under test now will be a set of classes.
Not
So
just a single
then
class
you need.
anymore. Yeah.
So then now you still have the two issues. How much do you put in that unit, right? So how do you define that? How do you define that boundary? So what is the unit under test now that you are putting more classes together? And then also, what would be the responsibility of the test? And this is where you start getting into design, because like the definition of that group of classes, they need to represent something meaningful, normally a bounded context or a subcontext or something like that,
Or a component, maybe. Yeah.
a component. So depending on how you, but it needs to mean something, and that definition now you are getting getting into the realms of software design. And so you need to be able to design those boundaries. And then if you have already tested at a lower level that test the correctness of each one of those classes, what would be the responsibility of the test that bring them together? It cannot be correctness again, because you don't want to test every single permutation of every single class that you have in that boundary, because you've already done that. So that's when the responsibility of test changes. So you might want to test the integration. Can they work together? Can I just have what are my sunny day scenarios through those but the responsibility of the test is also different. Not only the boundary, but the responsibility. And this, the further up you go, the more related to software design and architecture, and also to business analysis, system analysis, and what the business wants from that system instead of just the correctness of the individual class. And that's for me is a very long answer to your question, but yeah, it's quite a complicated one as well.
Yeah, so I understand completely that when you look at it from this perspective, it's very difficult from a young person without too much experience to write a correct class. Did you what are the, let's say, the most common anti-patterns that you would recognize in writing, let's say, just unit tests or some integration tests?
There are many. Those anti patterns, like they really depends on, again, the seniority. Like at Cogenius, we just released a TDD anti patterns PDF book. It's on our website. So there are a few of them that are well known, and there are some of them that I perceive. For me, it's difficult because I've been doing TDD for such a long time. But for example, I believe that the worst anti patterns are, I wouldn't say that there are the worst anti patterns. I think that the biggest problems that comes with TDD is the ability to design software well, is the ability to define the boundaries of what you want to test, and the ability to define what do you expect those tests to achieve. This is, for me, is where everyone or most people will struggle, is they don't know how to design and they don't know what the test should achieve. So yeah, I even went further to saying that we should teach people how to design software even before teaching them how to test drive.
And how do we do that? Like, are there any resources that you could recommend?
Yeah, so that it gets very complicated because, like, the material related to software design and architecture, and I make a distinction between the two. It's very spread, and it's difficult because we build systems very different. So the systems are very different from each other. So, but you need, for example, we do a lot of work in terms of understanding bounded contexts. So this is still, for me, somewhere in between software design and architecture. But being able, in order to define bounded context well, you need to understand the business well. You need to speak to business, see how they talk, how they are organized, who owns what kind of data, what are the different operational requirements that you have for each parts of the systems, where those changes come from, right? Come from the same person for different groups of people. So all of those forces that will make an area of the system to evolve. Do we have certain areas are used by external users, certain areas are used by internal users, certain areas are used by other systems. So it's all those different perspectives. I don't have an answer to your question. I don't know how to teach people to do that. The only way that I know is the more classical craftsmanship apprenticeship program, where you have junior people or people that are less experienced, let's say, working with more experience, and see them speaking to the business, sketching diagrams, creating designs, applying them, see how they perform, and then rejuggling them. You need to see people doing and learn by doing it. You cannot
by experience, not just through some books or podcasts or whatever.
The books can give you a good theory, can give you, for example, the books will help you to build a vocabulary. Similar to design patterns, right? So if someone says, "Oh, we need a repository here, or a DAO, or a service, or whatever else," you have the vocabulary, you know what they're talking about. Or we need to do a event sourcing here, or CQRS. You know the vocabulary, we know what they're saying, but you need to work in that project.
Yeah, to actually have it in your hands and to understand what it means when you read about it in the theory. Yeah. Cool. Thanks. And so let's say someone, another question, what are the other, let's say, quality metrics or the things that you look when you get a new code base that help you decide if it's a well-designed software, if it's a good quality code base or it's a bad code?
This is a thing that we've been discussing a lot recently internally, and there are things that I consider. I'm using the name that one guy internally said, that almost like hygienic metrics. The hygienic metrics are things that you get from SonarQube, for example, or all those static analysis tools. I think that, the reason I say hygienic metrics are the number of unused imports, or the size of a method, or like the cyclomatic complexity of a specific class or method and stuff. So for me, this is pure hygiene. Right, so you should not have those warnings. You should not have those errors. You should just clean that thing. Work
It
with
can be
format.
automatically even cleaned, right? You don't have to.
Exactly.
Most of it.
So you should not even be able to commit, as in most places you would have, like, if you don't satisfy a specific set of static metric, it will not allow you to merge or to raise a pull request and stuff like that. So, but what I'm trying to say with the hygienic practices, they need to be there. So you need to be able to wash your hands before you operate someone or you eat a food, right? So it's the same thing. But they alone are nowhere near enough to say that a software is well designed. Because again, those static metrics, because they are so low level, they will never tell you if for example, if the name is correct, if
the code readable,
correct. Exactly. So if your bounded contexts are well defined. So for example, then you start connecting to higher level metrics. There is a tool that I think it's quite cool. I still haven't seen it used well, at least in our projects. I believe that other people had more success, but it's called Code Scene.
Ah, okay, I've seen it by Adam Thornhill, right?
Yes, Adam Thornhill. So this, we saw it's applied in one of our clients. We still feel that it could have been better applied. We tried to influence, but again, that's a separate story. But the one thing that I like about tools like that is they bring a different perspective. They bring a more dynamic perspective. For example, they will say to you, what are the hotspots of your code? So areas that are changing more often. But most interesting than that is you can configure the different teams. So for example, team A, B, and C, and they have all those different people and stuff. So you can see how many different teams are working in the same area of the code. Because if you are having different teams that supposedly work in different areas of the code base, but they are changing the same files. So either the workload is not being well defined, or the code is so messy that everything is entangled. So those are metrics that for me are very interesting when you start seeing, because what we would like to achieve. Why do we have so many different teams? The idea is that we could have more parallel work being done by all those teams with very little impact. Exactly. So then they can own the pieces of work. They get their user stories, their epics, or whatever, and they go all the way to production without impacting anyone else. So for me, any metric that starts showing the conflicts. So the code scene will talk about the code, but you can start having metrics for example, on Jira or other tools that you say, look, your QA cycle is too long. You need to wait team A to finish what they're doing so team B can do something else. And because now you start seeing different perspectives, that, as I said, there is the work organization, but there is the status of the code base. A well-designed code base would allow different teams to work in isolation with freedom, given that the organization of the work is also done well. So those are things for me that I start looking off the quality of the code base. It's not only, I don't like the low level metrics so much, as I said, because it's a lot of preference. Oh, I prefer methods with 5 lines or 6 lines or 7. It's irrelevant. In the big scheme of things, it's completely irrelevant.
Yeah, I agree. Right. Yeah, and it does not have to point to how readable or well-designed code is.
Exactly.
You can have perfectly clean code by those metrics, and yet it can be very difficult to maintain.
Exactly. So those are the things, and then there are the accelerate metrics as well. The 4 key metrics that are much higher level. How often do you deploy? How often something goes wrong in the in production? How easy, how quickly you can change things when they go wrong. So is those, what is the time between someone committing piece of code and then going to production? So all those different 4 perspectives, they are related to process, but they are also related to the architecture and the design of the systems. Because you can have a great product, but if your system is messed up, you are not able to achieve those things.
Yeah.
So that's how I look at metrics, a bit more higher level than the Sonar Cube ones.
Yeah, it's more complex than that.
Because we are focused on the outcome. We are focused on maximizing value, maximizing the value that each team, each group of people will bring. And for that, they need well-designed systems. So you need to look at metrics that are higher level.
Higher level, yeah. Cool, thanks. And how do you how to say make a distinction between let's say a mediocre developer to good developer to great developer, or how do one progresses from one to another to the greatness?
Yeah, this is the thing, right? So it's difficult because I think maybe there are things that are common across any company, and there might be some things that are specific to some companies. And I'm not always understand the boundaries, because I don't understand every company out there either. There is what we already discussed is the multiplication factor. Is someone that is far more versatile. I like the idea of versatile people. And people that are versatile are people that there are certain areas that they understand very well. They are a specialist. It's a whole T-shaped kind of thing, right? So there are areas that they really are very good at, but they can multiply the job. They can make sure that they organize, but not only other people. For example, they have the end goal in mind. They are able to create those pragmatic boundaries and say, like, they are able to work with their clients, their customers, and whoever's paying their salary.
Understand the business perspective, right?
Exactly. What do you want to achieve? And we will come up with a solution that will satisfy your business in the best way possible, right? And I think that a good software professional, I would extend that definition not beyond a developer. I would call it a software professional. Is someone that is able to do that. You know, it has a much more holistic view of
not just the task in front of him or her, right? But
yeah,
the whole project or the whole product.
Yeah, because another thing that not always, for example, as I said, when I wrote the book, I wrote that with one or a few perspectives in mind, but I didn't really have other perspectives so strong as I understand them today. But for example, you as a professional, if the value that we bring is just to pick another user story and then make sure that it's done, one way of looking at the value that you bring is how many other people can do that, right? So, and if the answer is almost every other developer in the planet, you start seeing that the value that you bring is smaller than you think. You might think that you can craft the code very well, but you still are operating with excellence in a much smaller, in a very narrow scope. But if you are the one that you are enabling that project to move forward and always coming up with different ideas, getting involved with multiple activities, while you still can be extremely efficient when you pick your user story and build the code, then you start seeing that there are fewer people that you'll be able to do all of those things. And that's when you know that your seniority, a different way of looking at seniority is, what is the value that you bring to the company that employs you? And you need to understand the more versatile you are, the more flexible you are, the more value you have. There's no doubt.
And how big a reach your is. It's not just the project, or maybe if you are engaged in outside of the team that you work with directly, and help other colleagues grow and be better in their work.
Yeah, how many projects, how many types of work that you can do, how many projects out there when they come in, when there are companies like normal companies will have different projects, and companies like ours, like Vega and Cogilance, for example, we work for other clients. So that means that we work in completely different technologies, completely different industries and stuff. How many of those, all those different projects, I would be a good fit?
Yeah.
Because if the answer is, oh, if it's not Spring Boot, if it's
Yeah,
not
I'm not
Java and
gonna
Spring
work.
Boot, I cannot do it. So your value is very limited.
Yeah, yeah.
Right.
Do you take efforts to explain it directly, like very bluntly, to your younger colleagues?
We do, because like what we created was internally. We have a kind of a seniority level, a skills matrix that we call, and we
Hmm.
have like 6 disciplines and 5 levels of seniority.
Okay.
And the mistakes that we've made in the past, when we were creating this took years for
Yeah.
us
It's a
to
process to create it. Yeah.
yeah. So because you need to create, and then you apply in a performance review, and then
Yeah.
you don't have the result that you expect, and then you change again and change again. So now we are a bit happier. But for example, one big change, we changed it from the things that people should know, because
Hmm.
that's how it started. Oh, you
Yeah.
need to know those things, and then everyone can say, yeah, I know this, I know that, I know that. And so then it's okay, no, you should be able to do certain things, and everyone could say.
Yeah, I
And
can
then
do
we
it. Yeah.
change it now it's all about the impact. So for example, if you are at a certain level, you need to be able to demonstrate impacts in
Hmm.
those areas. So if you are for example, we have one of uh, the disciplines is leadership. So you cannot just say, oh yeah, I can lead a team. No, you need to show the impact. So what is the impact of a leader? So I've been enabling the team to work better. I was able to organize the work, or I defined some things. So what they need to show the impact that they're having in there. Other people agreeing with their so they go there and solve a problem. They identified an issue. They created a meeting. They brought everyone together, ran a workshop, created a plan, and now the whole team is following that plan. So that is a clear example of this is I was leading that process. I identified the problem, I discussed the solution, and I was able to bring people along.
Yeah.
Right. So that's what we discuss is like what is the impact that you are having, and now all our job descriptions in all levels and stuff, we always talk about what is the expected impact. That's where we
Hmm.
start from, and then we go into knowledge and behavior.
Yeah, but knowledge is just an enabler to create an impact on
Exactly.
your
Yeah.
surroundings.
And behavior as well. So because like knowledge was easier, we got to that conclusion quickly after a few iterations, but then we focus, no, people should behave in a certain way. But even the behavior is still an enabler for an impact. The impact is like the actual, for example, how do I know a project is a success? Well, a client wants to continue, they want to
Yeah.
grow. So it's not that, oh, because we build a good architecture. Well, it's pointless if the client doesn't want to continue. Of course, there are things that maybe they ran out of money, maybe the project was canceled for whatever reasons, but like the success is someone being happy with your work and wanting more. For example, another thing that we had for team leads and stuff, every now and again, people say, look, I don't want to be in this project anymore, or I don't want to work with that person. So a team lead should take care of that. You
Handle
should
it.
not
Yeah.
have people say, I don't want to be in this project anymore. Because if people are asking to rotate, you are not doing a great job as a team lead that are fixing those issues. Right. So is this kind of thing that the impact is very important, you know?
And this is how you go from, let's say, mediocrity to greatness. So not just the
I think
technical
so.
knowledge, but actually what you do with your knowledge and how you
Exactly.
work with people and within the business domain
Is the
boundaries.
size of impact that you can have in an organization.
Yeah.
That's where you see.
Yeah. And so I assume that you, as well as we do, have, let's say, some projects that are in the maintenance phase
Hmm.
and maybe created with an obsolete technology. So if you had an opportunity, to work on such a project, so it's for a long time in production. You have to maintain it, but it's not the bleeding edge technology. Or go with the, let's say, with the brownfield or a greenfield project where you can do whatever you want from the beginning. Which one do you think gives you, as an engineer, more opportunity to grow, to learn new things, and to become great?
So I think we need to distinguish, just for me, for it to be clear to me, like there are completely different extremes where one you are starting everything from scratch, and the other one is like the client already said, this is dead. We might make a change here and there, but the client is not interested. So this last one, so for example, you need just to keep the lights on. So for me as an engineer in that team, I was like, how can I make the almost the work of everyone here almost redundant? We automate so much of this thing that it gives zero maintenance. And when we need to a feature, it happens like that. So no one wastes time with this, because the client already said that this is dead. And it's just waiting for something else to be done, and then they're going to kill this. In that case, a good engineer would say, you know what? If that is the state of this project, let's reduce all the work that is done here, so that things that are not very strategic, you should not spend a lot of time. So a good engineer would automate the shit out of it.
And that's also a complex problem to do it, probably.
Totally.
Right? It's not a trivial task.
And that could be extremely exciting, right? So I've always been very good with my own career to always find motivation to myself. I don't think that is anyone's job to make me happy, exactly. Right? I can take the shittiest situation ever and put a positive spin in my head and say, you know what, that's what I need to do. This is my job. How can I make the most out of it? Yeah. So, but there are other systems that they are legacy. Well, they are big, they are old, but they are still quite core. They are still in evolution, and they will remain in use for the foreseeable future. For example, those are what we call internally as software modernization. We have a lot of projects in that area. And those are the ones that I like the most personally. I like to work with very large and complex systems that are old, and we have the opportunity to take parts of it, not the whole thing, because it's quite often not worth it. But take the opportunities to optimize them, to improve them, to modernize and stuff. And those are the projects I personally like the most, because the challenges of doing that at that scale, they excite me a lot.
And it's probably much more complex than just write new code.
Exactly, because you need to deal with a software that is already in production. Quite often, depending on the system, we work with very large systems, and they have loads of transactions happening every day. They have live customers using that and stuff like that. So they have tons of different dependencies. And so dealing with that kind of challenge, I personally like a lot. Is the favorite area for me is software modernization. I love it because you need to know the old extremely well. You need to understand not only old technologies, but you need to understand how companies work, because there is a change of culture as well. There is a reason why that system became what it is. And you need to know the new, because you need to be able to trace a line from where you are to where you would like to be. So you need to be able to define what is new and how you're going to get there. So I like that work a lot. But there are, of course, in any greenfield project, you are going to also learn different skills. Probably how do you define a product, how you're going to prioritize what features, how do you do an architecture that you need to evolve quite fast, because there is also a difference. For example, if you are building a system with a kind of a lean startup model, where the business knows that is an experimental thing, that you're going to be changing constantly. So the way that you architect a system to have continuous evolution, continuous change, and quite often significant change, will be very different from building a new system from scratch, but that already has, like a B2B, already has a very well-defined set of clients and stuff. So those two mindsets, although they are greenfield, they can be designed and architect completely different, and you can have a completely different experience in doing them. One, you need to optimize for fast evolution and changing pace. The other one, you need to optimize, get one feature after another, make sure they're production ready and they're adding value straight away.
Yeah.
Right. So I think that again, it's been a very long answer to your question, but if we all, as professionals, if we understand that it's our own job to make us happy. It's not my employer's job to make me happy, right? So then, if I take that responsibility to myself, you can put me in any project, and I will
And
be
make it
great.
interesting. Yeah. Yeah.
Exactly.
Cool. Yeah, but I think that's the point, actually. No matter what kind of project you work on, you can make it interesting for yourself if you are motivated enough, to solve the actual problem and to
Exactly.
provide value to the business.
Yeah. Exactly.
Cool. Thanks. A completely different topic. Let's say it's something that's very hot in the last, let's say, couple of months, maybe half a year or more, is the AI work within the software engineering. So, do you have any experience with it? Did you play with it? Try to use it in the creating the actual production software? Or-
A bit. Like I myself, very little. So I have like other people inside Codunus that share their experience and stuff. We even had a fireside chat discussing about AI. So I assume that you are talking about things like Copilot and things like
Yeah,
that.
yeah,
You
yeah,
know?
exactly.
So I think that every evolution is good, and I think that this is probably one of the most radical ones that we had in a very long time.
Yeah.
I don't remember something so radical, right?
So having such a big impact on our daily work
Yeah.
or engineers' daily work.
Yeah. So the way that I look at it is, I think that like everything, we should be careful in how we use that information. But I would embrace it. Because like I see some people saying, oh, but that can give you the wrong answer, that can give you this and that. Oh, for God's sake, like people go to bloody Stack Overflow and other places and they Google for stuff, like you can get a lot of wrong answer everywhere,
Yeah, you have
you
to be
know.
responsible with how you use the answers.
You can get wrong answers today. So someone was saying to me on LinkedIn the other day, oh, but those things can give you a lot of misinformation. I said, like using chat gpt
Yeah,
to I don't know, to do some research and stuff like that, and the person, no, but it can give you misinformation. So more misinformation than the internet as a whole when you Google something,
exactly, exactly.
or when you watch the newspaper, or on you even when you speak to other people, misinformation is there everywhere. So for me, those things are just a different source of information.
Mhm.
So I would see that with good eyes. It can optimize our work. It can speed up the work. But I would never say that it would be a replacement for our brain.
And for the
Right?
creative work, you have to do the hard work yourself, and it can
Exactly.
take out the boilerplate from you. Just
And another way of thinking, for example, my like I graduated in 1997, so it's been a long time since I graduated. But I remember back then I was really into coding already, and that was like the internet was in its infancy
yeah,
in the late 90s, right? So and a friend of mine uh, in my class, he wanted to go more on the business analysis and stuff, and I wanted to remain a developer, and he challenged me and said, like, why don't you write your dissertation about the he was saying back then that the programmers would be dead soon. And then I did my dissertation about that, and I learned doing the research that they were predicting the developer to die since they created COBOL. So
wow,
when COBOL came along, because before they were doing assembly,
yeah,
so when COBOL came in, that they were writing things in a thing that resonated with English. They said, no, now programmers are going to die because anyone will be able to write code. And that was the same when C and the C-like languages came in, because now you had ifs and for loops and stuff. And so now any person will learn how to code, and developers would die. And the dissertation was, what was changing is that our building blocks were becoming bigger, right? So instead of working at the byte level,
yeah,
we were working with bigger building blocks. And that evolution kept coming with the 4GL languages and so on and so forth. But what also happens with that, with the evolution of hardware, the complexity of our systems also evolved alongside. So our building blocks were larger, but the complexity of our systems also became much larger. So again, long answer, but like I feel that the AI, uh, the help from AI will make our speed faster to
Yeah.
figure out what needs to be done and rely on more information at the tip of your fingers while you are coding. So this will allow also us to operate at a higher level.
And maybe innovate our daily work with something new.
Exactly. But you still need to understand what's going behind the scenes. You still need to interpret that information. But I foresee us operating at a much higher level and be able to become more productive as it happened throughout our history. That's how I
I
see it.
Yeah, I agree completely. I think it's pretty much similar with the low code or no code platforms. So now there's, let's say, a big movement, and even some enterprise companies are using it on a such a high or on a quite a high scale that they are, let's say, calling it citizen developers, where their non-IT employees can create some applications, but still there's how to say there's a distinction on the governance over those applications, whether it's, let's say, an application for myself and my nearest colleagues or something that has a bigger impact. And there's, let's say, security concerns and data protection concerns that cannot be done by those citizen developers, but someone who has uh, more knowledge in the IT has to do it.
It's for me. It's this again. It's all part of the same evolution. For example, like when I started my career, I remember that some of the first system that I worked commercially was to control stock. Someone had a warehouse in Harbor in Brazil, and they needed to control their stuff. So we spent months, if not a few years, building a stock management system. A few years later, 5, 10 years later, you could buy from a CD, right? So
Yeah.
you buy a package, and so, but we didn't lose our jobs. But no one would spend that effort now building a stock management because you buy off the shelf,
Mhm.
unless that you have like a very different thing that is unique. Probably Amazon in there with their robots in their warehouses, they might have a lot of custom stuff. But a normal person controlling their stock in a small shop in the high street, they buy off the shelf. So the for me, the low code, no code. For example, we use no code internally.
Mhm.
Our internal processes to control some of our financials, salaries, even some allocation of people in some internal processes, we use a no-code tool to do that. We didn't want
Mhm.
to use our own people to build it because it was just not worth it. I just hacked with a no-code tool for a few weekends, and I put a few processes in place. But those are not the things that makes us unique. It's not our core product. It's not the no one will look at us and say, oh, they are better than the others because the way that they manage their internal process, right? So I think that no code and low code are good things, mainly for things that are operational stuff that you want very quickly and change and very easily to change. But I think that cases where people will use them to their strategic product, the thing that is their unique selling point, the USP, I think that you have very few cases. It will not be the norm,
Yeah.
right? That's how I see. But again, I also embrace them. I think they're a good thing.
Yeah, they can speed up, as you said, creating the operational or coding the operational processes into something that we can use in the everyday, but it's not something that can be maybe used in a higher scale.
Yeah, no, no, I don't think so. And even when they get more powerful, again, our systems become more complex as well,
Yeah, and
right?
goes one
So
after the other.
exactly. So everything that becomes more standard, more common across companies, they will be automated one way or another. Either you buy from off the shelf, or you have a very low, uh, a not so expensive way to automate. Because the same way that you guys, I don't know, control your finances or allocation should not be that different from how we do and then any other company similar to us will do. So those things you want to do in the easiest and cheapest way possible, because that's not where the differentiator is, you know.
Yeah.
So
Cool. Thanks. And well, just one last question to conclude our talk is, so after this talk about the low code, no code, and the AI, do you foresee a software engineering as being, let's say, a long-term career even for young people in their high schools now, or should we think about something else then?
I know, totally. I think that we are here to stay. As I said, what changes is the building blocks that we use, and the complexity of the problems that we work on. I think that's what when I look at, like, I've been in the industry for 25, 26 years now, and as I said, I like to think that I know a little bit of our history as well, of where we came from even before I joined the industry, and this is what I've been seeing consistently: building blocks becoming more coarse grained, but the complexity of the systems also becoming like, oh, today we talk about integrations everywhere. So we don't build a standalone stock.
Components and single applications, yes.
No. So look at the kind of craziness that we have with serverless architecture and APIs everywhere and real-time information and the amount of data that we are combining, AI, machine learning, all that kind of stuff. So the complexity of our systems are evolving. And it's natural that the building blocks that we use to tackle that complexity also need to evolve. We cannot just imagine doing all of that in assembly. That would be madness.
It would be madness, yeah.
So for me, the software engineer would still remain. It's just the level of abstraction that we work that changes.
Yeah. It will evolve into something more complex.
Yeah, totally.
Cool. Thank you, Sandro. Thank
pleasure.
you for taking the time to talk with me. It was a great pleasure. And I hope to be able to talk to you sometime soon again.
Yeah, no, absolutely, my pleasure. And I'm very happy to see also all the progress that Vega IT is making. I remember when I met you all many years ago, you were a much smaller company. It's a pleasure for me to see the success and the growth that you are having. So congratulations to all of you there.
Thank you. You're very kind.